So this one says, a triangle has a base that is increasing at a rate of 2 centimeters per second, but its height is decreasing at a rate of 1 centimeter per second. Can we find the rate of change of the area of the triangle when the height is 6 and the area is 27 centimeters squared? So I'll draw just a right triangle. Alright, so this triangle has a base. Yeah, I'll call the base B, and the height can be H. They're saying that the base is increasing at a rate of 2 centimeters per second, but the height is decreasing, which means that in the next instant, triangle may transform into something like this. Alright, so where the old base would be called B, the change in the base would be called dB. And here I'm just referring to this part here. Then the old height was the whole thing, but this little section here would be dH, the change in height. Now they give us a few things in this problem. They tell us that dB over dt, the change in base with time, is going to be 2. And then they tell us that the change in height with time is going to be 1, but it's a negative 1 because it is decreasing. They want us to find the rate of change of the area, so they're asking for dA over dt. How does the area change with time? Okay, they tell us here that the height at the current time of analysis needs to be 6, and the area at the current time of analysis needs to be 27. So with all that in mind, we should come up with a formula for area of a triangle from geometry. Area equals 1/2 base times height. And we now want to differentiate implicitly using this geometry formula. So area is changing, so that's variable. 1/2 is a constant, but the base is variable, and the h is also changing as well. So because all of these three things are changing, we have to treat them as functions, and we may have to use the chain rule on each of them. Just making it clear what I'm doing. I'm figuring the derivative of just a variable is going to be 1 dA. But when you do the derivative of b times h, that requires product rule, because it's two variables multiplied by each other. So we should do product rule, which says that anytime we have two functions and we're finding a derivative, we'll do the derivative of the first function times the original of the second plus the derivative of the second times the original of the first. So I would make this then dB times h plus dH times b. Now we could just try to simplify a little bit. And my next step would be to divide all terms by dt. So we can get a relationship between the rates. Now dA dt is what we're looking for. And so see here, h needs to be 6. So replace that h with a 6. 6 goes here. dB dt was stated here to be 2. So that needs to go here. For B, we don't know what that is. So, okay, we're going to have to leave that as unknown. But we do know what dH dt is. It's -1. Plug in a -1 here. And now we have almost everything we need. We just need to know a value for B. So at that point, I would go back to my triangle formula once again. And so we could say that at the current time of analysis of this problem, they're saying the height is 6 and the area is 27. So we can plug those things in. I plugged in h and I plugged in 27. I could now solve for b. I get that b must be 9 centimeters. So now we really have everything we need. Put the 9 there. And we can now get our final answer. I get 1.5 centimeters squared per second.